Hi everybody, this is Miss Lorette. So for this presentation, I'm going to be continuing to review section 1.2 for Honors Algebra 1. If you're in my class, some of this stuff you may have seen already when I talked about it on Friday. So there may be a few moments at the beginning of the video that you want to skip over, unless you want to continue watching it just for some extra reveal. So let's get to it. So the first thing that I want to review is the concept of what an exponent actually is. So an exponent actually tells you how many times to multiply a number against itself. So that's what I'm going to write as my definition. So the exponent of a number says the number of times to multiply a base, so I'm going to use a very special word here, a base, against itself. And I'll talk a little more about what that means in just a second. So here we have an example of an expression that contains an exponent. So the entire thing, we actually call it a power. So when we're looking at the entire expression as a whole, when I look at that number in blue, the 4, that's actually the base. That's the thing that we're going to multiply against itself. And then the little number in the corner, hopefully you already knew, this is the exponent. So what this is basically telling me to do is to take 4 and multiply it against itself 2 times. So I would do 4 times 4, which would give me 16. Okay, so now let's take a moment, and feel free to pause the video if you need to copy this table down, and let's do some practice where we identify a base and an exponent. So my cohort B students, even though we kind of talked about exponents a little bit on Friday, you may still want to do this part just because it's very good review for identifying what the difference between an exponent and a base is. Okay, so hopefully you've taken a moment to copy down this table and all of the examples. Let's start with a really easy one. For number 1, the exponent is just going to be that little number. So my exponent for this one, let me change to a darker color, is going to be 4. And my base, which is that larger number, is going to be 3. Let's try number 2. So my exponent, again, is going to be that little number in the corner. Here it's 4 again. And my base in this example is just going to be x. So your base can be a variable. Number 3 is where things might get a little tricky for students. So let's do the exponent first because that's the easy part. It's just 3 because it's the little number that's in the corner. But now we have to think, is my base the 7, the y, or both of them? So the idea here is to look for parentheses. The general rule of thumb is if you don't see parentheses, the only thing that is your base is the thing that's directly touching the exponent. Anything else is an extra operation that's happening. So here in this case, the only thing that my exponent is directly touching is the y. So this 7 is actually being multiplied against this power, y cubed. So the only thing that is my base here is y, and 7's just being multiplied with it. Now let's take a look at number 4. Again, we'll start with the easy part. My exponent's that little number in the corner. My exponent is 5, but now I do have parentheses. So in this case, because this entire sum of x and 5 is contained in parentheses and the exponent is on the outside, this entire thing, x plus 5, is my base. So my base isn't just the 5 by itself, it's the entire sum, and it's the parentheses that make that happen, excuse me. Okay, so let's take a look at number 5. Again, my exponent is just going to be that little superscript in the expression. So my exponent here is the variable x. Now I need to think about what's my base. again, if you don't see parentheses, the only thing that's your base is the thing that the exponent's directly touching. So the thing that the exponent's directly touching here is the 6. It might be a little easier to rewrite it like this. If I wrote it as a vertical fraction as opposed to a horizontal fraction, then you'll clearly see that the exponent is only affecting the 6, and then the divided by 7 is kind of like the times 7 in example number 3. So my base here is just 6. A little more complicated still, number 6. My exponent, again, is that superscript, and in this case, it's not just one value, it's an entire sum. That's okay. I'm just going to list it as my entire exponent. If it's a superscript, the entire thing is your exponent. And I see parentheses, so because my exponent's on the outside of that set of parentheses, everything on the inside of the parentheses is my base. So my base here is not just the e, but 5 times e. And lastly, number 7, the superscript tells me what my exponent is, which is 16, and everything's contained in parentheses here. So everything in that set of parentheses, the entire quotient that we see, that's my base. Okay, so speaking of parentheses, let's talk about how a negative sign comes into play when we see parentheses versus not seeing parentheses. So as I mentioned, if you don't see parentheses, the only thing that is affected by the exponent is the thing that's directly touching. So if I see something like this on the left-hand side where I see a negative, but I don't see parentheses, that's kind of like saying -1, because there's an invisible -1 that's getting multiplied with 3 squared, okay? So the negative in this case is actually not a part of our base. What we're squaring here is the 3 and then multiplying it by -1. So if I do that, that's actually going to give me 9 when I square the 3 first, and then if I multiply by -1, that gives me -9. So the general rule of thumb here is if you have a negative, but it's not in parentheses, your answer is always negative. Okay, no matter what. So even though I'm squaring it here, and you would think that the 2 negatives are going to cancel, you have to remember the negative is actually not being squared. Only the 3 is being squared. Okay, so let's take a look at this example. Now my negative is in the parentheses. So what this is actually telling me is I'm going to take the -3 and I'm going to multiply it against itself 2 times because the -3, including the negative, is my base. So let's think about what we would get as an answer. Well, 3 times 3 gives us 9, and the 2 negatives would cancel out, leaving us with a positive. Okay, well, now the question is, do I always get a positive if the negative is a part of my base? Let's do one more example. Let's say instead of squaring that negative, squaring means I have an exponent of 2. Let's say I was cubing it, meaning I have an exponent of 3. So what this is telling me to do is do -3 times -3 times -3. Well, I just did -3 times -3 to get +9. So if I take that answer and I multiply it against that last -3, I'm going to get a -27. So this is a little more complicated. So I could get a positive or I could get a negative. The trick here is to look at what type of exponent you have. Notice that 2 is an even number. When I multiply an even number of negatives, all the negatives cancel and I'm left with a positive. If I have an odd exponent, like 3, 5, 7, 13, all but one of the negatives will cancel, meaning I'll have one remaining negative, which will end up being in my answer. So I'll end up getting a negative answer. So the general rule of thumb is if your negative is part of the base. Actually, I'll clarify that. Is in parentheses. I think that's going to be easier to remember. But part of the base is also valid. So is in parentheses. You have to look at the exponent. If your exponent, did I spelled that correctly, is even, numbers like 2, 4, 16, 20, you're going to get a positive answer. If your exponent is odd, numbers like 7, 9, 21, you're going to get a negative answer. Okay, so excuse me, just something to keep in mind when you're evaluating things and simplifying things with order of operations. If you see exponents, you got to be careful. The first thing I would ask myself is, do I see parentheses or do I not see parentheses? If you don't see parentheses, your answer is going to be negative no matter what. If you do see parentheses, you'll want to make sure to make your answer positive if the exponent's even, and make it negative if the exponent is odd. Okay, so let's do a little bit of practice here. And you can verify stuff with a calculator, but a lot of this we might be able to do without a calculator. In fact, the first one, there's a trick to being able to do this problem without a calculator. If you have 10 raised to any power, then all you do is you write 1 first, and then you write the number of zeros that's equivalent to your exponent. So in this case, I would add 7 zeros to my answer. So 1, 2, 3, 4, 5, 6, 7. So that's a trick for powers of 10. You can do that for any power of 10. So you don't even need to use a calculator here. For this fraction, the entire fraction, again, is contained in parentheses, so I know the entire fraction is a part of my base. All you do is you apply this exponent to both the numerator, meaning I'm going to cube the numerator, and to the denominator, meaning I'll cube the denominator as well. So if I cube the numerator, 1 raised to any power is just going to give me 1. And if I cube the denominator, that's going to give me 8. And if you have a fraction that can reduce before you raise it to an exponent, it is highly recommended that you reduce first before you apply the exponent. Otherwise, your final answer will need to be reduced, and then you're reducing much larger numbers. So always make sure that before you evaluate a power, if it's a fraction, to make sure that that fraction is simplified. And then let's practice a decimal. I'm actually going to use my calculator just to make it a little faster. So if I square 0.2, I'm going to get 0.04 as my answer. Okay, whoops. Okay. So I would actually pause the video here and give some of these a try. When you unpause the video, I'll show you guys the answers that you should have gotten. Okay, so here are the answers that you should have gotten for each of these. For number 4, 5 cubed should have given you 125. If you square 0.5, you should get 0.25. If you raise -2 to the power 4, you should get positive 16. The reason it turns out to be positive is because my negative is a part of the base here, but my exponent's even. So all those negatives end up canceling out when that's the case. The last one, the fraction is in parentheses, but the negative is not. So since the negative is not in parentheses, my answer is going to be negative no matter what. 3/4 doesn't reduce, so I know that whatever answer I get after I cube each of these numbers, this will also be reduced. 3 cubed should have given you 27, and 4 cubed should have given you 64. Okay, so to my cohort B students, As I mentioned, we talked about some of this stuff in this presentation already. If you were here for this slide when we looked at Shyla and Kai, feel free to skip this part of the video, or you can keep watching for extra review. For everyone else, definitely keep watching. I always like to show this slide to my students to try and kind of have a little debate in class. So Shyla and Kai did the exact same problem, but they're getting two different answers. And the question is, why? What did Shyla do that was different from Kai? And also, who is wrong, who's right, and why? So before we talk about that, let's just do a quick review on what the order of operations are. And I encourage you, if you're in class with your teacher, to pause the video and maybe have a discussion about who's wrong, who's right. Maybe have a vote in class. How many people think Kai is right? How many people think Shyla's right? And then order of operations, which is what everyone should have been taking notes on Friday. Order of operation, we use this acronym, PEMDAS, to represent order of operations. So as you can see, I have more letters than I have steps here, and there's a reason for that. Let's go ahead and review what each of these letters represents. The P stands for parentheses. Now, we use this term vaguely here. We don't only mean parentheses that looks like this, the curly parentheses or the curved parentheses. You could also see square brackets or braces, whatever you call them, or you could also see these curly Q braces. Anything like this that represents grouping, that's what you would do first. The next step in PEMDAS is E, which stands for exponents, which is why we did all that exponent review. And the next two letters I actually put together. I lumped them together for the same order of importance. M and D stand for multiplication and division. And the reason I put them in the same step is that you don't necessarily multiply before you divide. Sometimes you'll divide before you multiply. The way that you know which to do first, you read it like a book. You do it left to right. And then same thing for the last two letters. I lumped them together for the same order of importance. You could probably guess what they stand for. It's addition and subtraction. And because they're the same level of importance, again, you don't necessarily always add first before you subtract. It's done in the order that you see it when you read the problem, left to right. Okay, so going back to Shyla and Kai, let's take a look at what they did again. Maybe even pause the video and have another discussion with your class. See if anybody wants to change some of their answers. Whoops. Clear annotations. There we go. Okay, so hopefully after reviewing PEMDAS, you have concluded that Kai is actually the one who's correct here. So both of their steps here, where my pen is hovering, is the same. This is where their steps differ, the very last line of work before they get their answer. What Kai did first was that he divided 6 and 2, and he got 3. What Shyla did was she multiplied first, and that was her mistake. And a lot of students fall into this trap. There's 2 reasons why she might have done this incorrectly. So one thing that she might have thought was, oh, the M comes first in the acronym, so I have to multiply first. That's one potential way that she got it wrong. Someone pointed out to me in my class that another reason why she might have got it wrong is because she saw the parentheses and got tripped up by that. Because parentheses, as you know, we have to do that first. But that only is done first if you have operations in parentheses, like this, where my pen is hovering. If I have an operation, or operations, plural, inside a set of parentheses, then that actually counts as a parentheses step. But if it's one singular number by itself with no other operations going on, and it's sitting in parentheses, that actually counts as a multiplication step. Okay, just something to keep in mind. Whoops. Okay, so another example, I guess we can call this person Shyla again for consistency. And maybe this is Kai again. So again, they have the same exact problem, but they're doing it two different ways. So this is kind of where I lost time with my cohort B students. So cohort B, if you're watching, which you should be, this is where you'll definitely want to continue the video to take your notes. So the only thing that's different about problems like this is instead of being given a numerical expression where it's all numbers already, here we have algebraic, where we have variables. All you do is you replace those variables with numbers, and then you do order of operations like before. So go ahead and take a moment to identify what each student did differently and talk about it. Okay, so hopefully you've had a discussion with your class and you noticed that what Kai is doing differently than Shyla is that when he substitutes for the variable m, he's enclosing it in parentheses, whereas Shyla is not. And as we mentioned before, parentheses, if including a negative when you're dealing with exponents, can affect the sign of your answer. So that's why they're getting two different numbers here. All of their work matches other than that. The only thing that's different is Shyla's getting a -16 and Kai is giving a positive. The question is, who's actually correct here? Well, when you think about it, we wanted to square the value of m. Well, what's the value of m? Is it 4 or is it -4? Well, when I look over here, the entire value of m should be a negative, meaning I also want to square that negative because it's part of the value that I'm substituting. So Kai, again, is actually correct here because when he did it, he included that negative in parentheses. So the general rule of thumb is, when in doubt, use parentheses when you're substituting for a variable like this. It's really best to use parentheses for exponents. But there may be other times where you have to use parentheses when you substitute. So I tell my students, when in doubt, if you're not sure if it's going to affect your answer, use parentheses, because if you use parentheses, you're guaranteed to get the right answer, or hopefully you'll get the right answer. Not necessarily guaranteed, hopefully. Okay, so let's do some examples where we have to do what Shyla and Kai did and substitute a number for a variable. You always want to make sure to read the entire statement very carefully. So I have y divided by 2 plus x, and I'm told use x equal to 1 and y equal to 2. So what I'm going to do is where I see a variable, I'm going to open a set of parentheses and replace that letter with the number. So instead of y, I'm going to use 2. I'm going to copy the divided by 2 because that's not going to change. Okay, so I'm just bringing that part down. And then I'm going to add x. Okay, now this is actually one of the problems where if you didn't use parentheses, you should still get the same answer. But start making a habit of doing it anyways. And at this point, I could just use order of operations. I'm going to divide first and get 1, bring down my +1 because I haven't done anything with it yet, add last, and get 2. Here's another example. So again, I see exponents, so it's important now more than ever that I use parentheses just to be safe. So instead of p, I'm going to use 7, and I'm going to input it in parentheses. And instead of m, I'm going to use 4. Again, I'm going to use parentheses just to be safe. And then I'm going to bring down that divided by 4. Now I can use order of operations to simplify. I need to do exponents before I can divide. 7 squared is going to give me 49. I'm going to bring down that 4 divided by 4 because I haven't done anything with it yet. And then I'm going to multiply and divide left to right. So if I multiply 49 and 4, I get 196. I'm going to bring down that divided by 4. Always make sure you're writing all of your work so you don't lose anything along the way. And then lastly, I'm going to divide. Sorry if you hear noises. That's my cat in the background. And I get 49 as my answer. Hopefully you guys don't hear her meowing. Oops. Okay, and then I believe this might be the last example. Let me just double check. Nope, I have one more after this. Okay, so second to last slide here. This one's looking a little more complicated. So as I mentioned, when you're substituting, it's good to use parentheses. But if you notice, there's a lot of parentheses in this expression. It might get a little confusing. So what I might do if I was substituting in parentheses here, I might actually change these parentheses to like different grouping symbols, like braces. So I might make it look something like this. A bracket, oops, and then another bracket, M plus Q, close square bracket, close square bracket. You're allowed to do that because, again, they mean the same thing. So now when I substitute in parentheses in here, it might look a little less complicated. So instead of P, I'm going to use 5. I'm going to copy that bracket, 9 minus bracket, and instead of M plus Q, I'm going to do 4 plus 3. So 4 plus 3, close bracket, close bracket. So if you've never seen a problem this complicated before where you've got a group within another group, I tell my students it's like the opposite of opening a gift. When you get a gift, you start on the outside and you work your way in. When you're doing a problem like this, it's the opposite. You work on the innermost part first and you work your way out. So the part that we should really be looking at first here, oops, is this part here. This is what I want to do first because that's my innermost set of parentheses. So I want to evaluate this first. So I'm going to copy down my 5 minus bracket 9 minus. And inside this innermost set of brackets, I'm going to add and get 7. And then close the last brace or bracket here. Now I can keep going. I still have grouping here, but again, it's one number, so I move to this outermost group, which tells me to do 9 minus 7. When I do that, I get 2. And then lastly, I do 5 minus 2 and get a final answer of 3. And the last problem, so 12k minus h squared. This number touching the variable, hopefully you know, means multiplication. This is important that I use parentheses here as well. The reason why I want to use parentheses here, let me just do something wrong over here. So this would be wrong. If I don't use parentheses when I substitute for k, here's what it's going to look like. So instead of 12 times k, what does this look like? Looks like 123. I lost the operation. So when we do this, we want to make sure that we're including parentheses when I substitute 3 for that variable k. And then I'll use parentheses again to substitute for the 2. Be careful here. This negative here is not supposed to be included in your parentheses, okay? And the reason why is because it's part of our original expression. It's not part of the number we're substituting. If we were substituting a negative, then we would want to include that negative in parentheses. But if it's already in your expression, you don't include it in the parentheses. Now that I've substituted, I can evaluate using order of operations. I need to do my exponent first. So I'm going to get 4. And now I multiply. So I'm going to get 36. And lastly, I subtract and get, not 2, but 32. And there's my final answer. Hopefully you guys found this helpful. Feel free to rewind the video if you need to watch it again, and make sure to ask your math teachers any questions that you might have. See you guys next time. Bye.